Okay, so let's get started. We're going to be taking a look at setting up a mechanical-based idle control tuning routine within our Motec M1 programming. And we'll find that we have the ability to go through and set up our idle control. If we don't have an idle control motor, so whether it's a pulse width modulated type of idle control motor, a stepper motor, or drive-by-wire. So if you're in a situation where maybe you have individual throttle bodies fitted to your engine and there's a lack of any type of idle control motor or drive-by-wire functionality, or if you have just say a basic single cable mechanical style throttle body, you're going to have to go in and set up a mechanical based idle control. And this is going to be utilizing your throttle plate opening in order to bring a certain amount of airflow into the engine to give us kind of a baseline of torque, then utilize spark timing feedback in order to dial in the actual torque that we want to have our engine run at to run at the desired idle speed. Now, we talked about the basics within our idle control in our last tutorial. So we know that there's something called a slow path and fast path in our torque-based dial control. So when we're talking about our slow path, that's going to be airflow based. Fast path is going to be our spark timing based control. So when we're dealing with a mechanical based idle control, we'll be finding that our slow path is a variable that we aren't going to directly control virtually with our Motec. That means that we're going to be setting our throttle set screw or the throttle stop, the minimum throttle opening, through the actual set screw mechanically. So that's going to be giving us, again, our baseline of airflow coming into our engine. That's not going to be able to vary. And then we'll find that we're going to be directly virtually programming, controlling our fast path of torque control. And that's going to be through our spark timing. This is the most simplistic way to go about dialing in and tuning your idle control, but it does build on the fundamentals of idle control here. So what we learn in this training module can be applied if you have a stepper motor. It's just going to add another layer of tuning complexity within our Motec programming, but we'll find that everything is going to be working hand in hand with each other. So in the stepper motor example, that's going to be what we take a look at in the next training module. That's a controlled vacuum leak. And so we're going to be able to vary the amount of airflow and the amount of spark timing. It's going to give us two variables to manipulate. In this simplistic mechanical-based idle control, we just have that fast path or spark timing to deal with. Let's jump in here and let's take a look at where we can find our idle tuning and talk about what we have to program for a mechanical-based idle control. So first things first, we're going to move from our field tuning page over here on the left, and we're going to jump across here into our idle tuning page right here. Now in our idle tuning page, we're going to find that we have all of the tables and parameters we need to take a look at to understand what's going on and to calibrate a mechanical-based idle control. So taking a look at this, we're going to find that we have to have a couple things established before we even go ahead and do any type of tuning or running our engine. We need to go in first and take a look at what we have set in our idle aim main table. This is going to be setting the closed loop target where we want to have our engine idle at. So mechanically now, we know we have our throttle blade that needs to be open a certain amount. We have the spark timing we can vary around. This is going to arm the Motec to have a target that it's able to move that spark timing, moving up or down our engine torque in that fast path of control in order to reach this desired idle speed and indirectly reaching a certain level of idle torque output. We're going to find that within the programming routine here, this 1000 RPM that we're shooting for right now, the idle aim main, this is going to get added to the idle aim compensation table. This is used for post start. So when we're firing off our engine, we'll find that whatever we have programmed here, at whatever the coolant temp is going to be, adds against whatever we program in here. Now, the aim compensation table is only used for the first few seconds of engine startup. We can find here in the axes, it starts here at 0 engine runtime, and then it ends at 4 seconds in this particular example. If we click A, we can change our breakpoint axes. We can also make this table based on coolant temperature and turn it into a 3-dimensional table. We don't need to do that. We can keep it 2-dimensional. It's pretty much all we need to worry about for right now. So what this is going to do is allow the Motec to have a certain target when we're firing up our engine, and then once the engine dissipates, it starts to come off this engine runtime 4 seconds after the engine's fired off. So 0 would be cranking, and then after it actually exceeds about 400 or 500 RPM, it starts the counter over here, and it goes here to 0. that means that then we're riding purely on the idle aim main values. So this is what we have ultimately for the target, but we do have to remember that these two are cumulative, so they will add together to give us that revised target. We can actually keep track of what this is doing in terms of this closed loop routine. If we take a look over here on our idle channels, we're going to find that we have our idle aim. Now, our idle aim is going to be the total amount of the idle aim main table here, plus any of the compensations that could be in play. So in this case, we can see here that we've programmed a value of 1,000 RPM. We're here approximately 60 degrees Celsius. And we can see now our idle aim main is showing 1,150. That's because we have 1,000 here plus 150. That's going to be where we actually fire off the engine. Now, once the engine is running, it will dissipate across here after a few seconds of runtime and go and taper itself down to 1,000 RPM. So the idle aim and idle aim main should match each other after the engine's fired up and ran here for just a little bit of time. We can also see the idle aim compensation that's showing us and exposing what the compensation amount is going to be. So the way this is going...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.